Welcome everyone. In this video we are going to see about social distance detection in Python using YOLO object, which is a part of machine learning. So first we are going to set up the variable value, like such as we need to initialize minimum probability to filter weak detection along the threshold value when applying non-maxima suppression. So such as we need to include three values. The one will be minimum configuration, and the second will be threshold value, and the third will be minimum distance. So first I am initializing all the values, and then this minimum distance is initialized to define the minimum safe distance that two people can move from like each other, the distance between the two people. Okay, so here I have provided the chart flow, or whatever you can say, the algorithm or the pictorial representation how this YOLO actually works. So first do we have this YOLO means nothing but a four-dimensional NP array. Like we will be creating the blobs, which mean that will be sent as an input. So that will be in a type of this 4D NumPy array. So at last we will be converting that convocational neural network. So we will be reducing those layers into a single layer to get an accurate output. So that is what we are going to do here. So let me see. Okay. First, we are creating a people detection function and we are calling that in our program. So first we need to import the necessary packages, and then we are uh, we are creating a function called detect people. So as I said, these are the four parameters which are needed the for detecting these people. So like we'll see in the program like where are we using this. So first grab the dimension of the frame and initialize the list of results, which means the parameters known as height and width should be given to the frame, and then we are constructing a blob from the input frame, and then perform a forward pass of YOLO object detector, giving us our bounding boxes and associated probabilities, which means the boxes should be defined in the video or like in the frame, so that like it will determine the probability whether the distance is being keeping upon or not. So the blob is being initialized to cv2.dnn blob from image, and then next we are giving, like we are setting the blob as an input, and then finally we are assigning the layer output to the forward progression which we use in this YOLO object detection. Then we are initializing our list of detected bounding boxes or centered or confidence and respectively. So nothing but we are creating a three empty list so that we can append it or like we can delete it later. And then like we are looping over each of this output layer. Again we are looping over each of the detection. So the frame by frame, like we will be detecting that, and like I mentioned earlier, if the previous layer has been detected, again I am detecting that, and if this layer has been completed, again this layer will be detecting the, like it will be reducing generally. So after that we are assigning and we are extracting the class ID and confidence, that means probability of the current object detection, and we are storing it in a score, which means the accurate result. After that, yeah, like we are excluding this class ID and confidence. Like confidence will be the score which will be stored as percentage, and then like filter detections by one, ensuring that object detected was a person and that the minimum confidence is met. So the biggest problem we will be facing in image processing will be whether we are capturing an person or whether we are capturing an object. Like say for example, if both are in the frame, if any of them is moving, so the camera should not identify the object as a human. Also the camera should not ignore the human as an object, right? So for that is what we are doing here. Fortunately we have a pre-trained model in our YOLO, so that no need to worry about this back end. Okay, So yeah, like 1 minute guys. So so we are generally uh, yeah so we are generally comparing this class ID with this person ID X, which means the person index, and the confidence level should be like more than the minimum configuration, which means the it represents the object detection. Okay, so the scale of the bounding boxes coordinates back relative to the size of an image, keeping in mind that YOLO actually returns the center x, y coordinates of the bounding boxes followed by the boxes width and the height. So this is nothing but we are creating a YOLO box, which means a rectangular one where we have been detecting the, I mean, like it will be surrounded within the human, so that it will be easy to identify the centroid. So that we'll be doing later. Here use center of x, y coordinates to derive the top and left corner of the bounding boxes, so that we can easily identify the centroid, right? After that, update a list of bounding boxes coordinates and centered and confidences. So as I mentioned earlier, like we will be appending, right? So we are appending the boxes, centroids and confidences. Then apply non-maximum suppression to a suppress weak and overlapping bounding boxes. So generally what we have done till here is we have been assigned like we have been took a function, and like we are assigning a three empty list called as boxes centered and confidence, and then we are pre-processing our data into, like we are resizing it, like we are reducing the number of neural networks, and at last we are appending to the YOLO box and centered and confidences. So like all of these three will be assigned to the particular parameters. So these three are very important for the this entire program. So and next we are coming to the indexes. How do we find these indexes? By simply giving us cv2.dnn. So no need to worry about, guys, this is a pre-trained model, so we can directly import it. And like we will be giving this, passing this four parameters. One will be boxes, confidence and minimum configuration, and last will be threshold. So then we need to ensure at least one detection is exists, which means if any of the person is in the video, then we are starting a loop that for each and every person, I mean the person index dot flatten means it's nothing but a value which will be searching in this neural network to overcome the overfitting. So and we are extracting the bounding boxes coordinates, which mean x comma y will be like we will be marking the boxes, and we are updating a result list to consist of the person and prediction probability, bounding boxes coordinates and the centroid. So we are doing that here, and at last we are appending that. So we are returning last the results alone. What is coming up next? Like we are creating a blob. What is an blob and how to create a blob? So blob is in nothing but that is an input layer. I mean, like sorry, that is an input to a network. And then how do we define that? So that we have mentioned here, and then uh, the parameters that we need to pass, right? So that is what mentioned here. The image to transform. Okay, after that we are giving the scale from 1 to 255, which means the pixel value. I mean next the dimension, I mean the maximum dimension will be 416 into 416. So after that the mean value, like that will be default as 0, and then swap br, which is equal to true, since OpenCV uses bgr, this is uses br. Okay, after that I am including my Google Drive. So this is nothing for, I couldn't download the YOLO weights and model if and also like I have been downloaded, I could not upload in my collab, so I have been using this Google Drive. And then we have came to the last part of the program. So nothing but we are predicting that. So we need to import all the necessary libraries here, and then we are constructing this argument and passing this argument. So this you can just see this, because this is nothing much important. Okay, cool. After that we are uh, passing the input video, or like we are passing that input video to this variable called args, and then we are loading the COO, that Coco class label, or our YOLO model was trained on, which means we are giving, or we are uploading the label path, and like we are uploading the path of our model name to the variable called label path, and then for this label we are opening that and we are reading in, we are like in line by line. After that, the same we are doing this for this wait path and this configure path. So after that we are printing just info loading YOLO from this. Then we are using this cv2.dnn dot readnet from darknet to compare the model, or to load our YOLO object detector trained on Coco dataset. So we have 80 classes, which means it can classify up to 80 objects. And then we are determining only our output layer names that we need from YOLO, right? So that is what we are doing here. And then we are initializing the video stream and pointer to output video file. So this is nothing but we are storing, and we are capturing the video which I gave the input link in the top, and then if that is not equal to 0, like this will be running, and then we are capturing this. So if that is true, this grabbed, like for each and every frame that will be read. If the frame was not grabbed, we have received through the end of the stream, so we need to break that. So for breaking that, as we are giving result is equal to detect people, so the function is being called here. After that calling, initialize a set of indexes and then violate the minimum social distance. Like if some of them has been violating the social distance, like we are setting the value for that, and then ensure that there are at least two people detection required in order to compute our pairwise distance map. So first of all, we need the social distancing is detected at least between two people. So that is what I have mentioned here. So you could see that I have calculated this centroids by extracting all centroids from the results and compute the decimation distance between all pairs of the centroids. So after that I'm looping it over to a triangular distance matrix, where to compare between a group of peoples, and then at last I am comparing or like to check to see if the distance between any two centroid pair is less than the configured number of pixels, and update a violation set with the indexes of the centroid pairs. At last we are looping over the results. So to looping over the results, and we are extracting the bounding boxes and the centroid coordinates, then initialize the color of annotation. Okay, after that, if the index pair exists within the violation set, then update the color, or else no need, and draw one on the bounding box around the person and the centroid coordinates of the person. So two steps have been done here. First of all, we need to draw the box around the person, and the circle will be on the person, or like it will determine inside the person. So draw the total number of social distancing violation on the output frame, and check to see if the output frame should be displayed on a screen, so that again we are passing that argument, right? So we are calling it. So if that is greater than 0, the video is been running, so output frame will be displayed. If we press Q, the program will be breaked and it, it will be breaked from the loop. If an output video path has applied and video writer has not been initialized, do so now. Initialize our video writer. So if we press upon the Q, the video will be stopped, and after that the video will be written to the particular file. After that, video editor is none. Like if the video writer has been done everything, then we are returning the frame. So this is what, just like I'm showing you this output. So you can very well see here, this frame will be for each and every second. So for each and every second, each and every frame is noted, and you can see different kind of peoples are walking, so and they are breaking the rules. You can see the number of social distancing violation is being increased or decreased with respect to the people's activities. So you can see, right? So this is what this project basically does, guys. I think you have been satisfied with my video. So thank you.